Okay, the segment addition postulate. We'll be using this postulate a lot. A postulate just means a statement that we accept as true, meaning we do not have to prove it. Okay, so the segment addition postulate says that if point B is between endpoints A and C, if we see our little drawing right here, we have our segment AC, and then B is a point between those two endpoints, A and C. Then we have the equation AC, which is the length of AC, is equal to AB plus BC. Alright, that means that the length of AC is equal to the length of AB plus the length of BC. Alright, so now we're going to use the segment addition postulate to answer to do some problems. P3 says use the segment addition postulate and the given information to complete each statement. So A, if B is between C and D, BC equals 10 inches, and BD equals 3 inches, then find CTD equals what? So what I like to do generally is to draw out my segment each time. So I have that B is between C and D, so that means we have a segment CD is the entire segment. So C, D, and B is in between somewhere. My drawing might not be to scale, so just be warned. I say that BC is 10 inches, so put that here, between B and C. And then BD is 3 inches, put that in between B and D. Okay, so use the segment addition postulate. The segment addition postulate tells me that CD is equal to BC plus BD. Alright, now plug in information that I know. CD, I do not know, so I keep it as CD. BC is equal to 10 inches, so 10 inches, plus BD, which is 3 inches. So 10 inches plus 3 inches gives me that CD is equal to 13 inches. And I'm finished with that one. Okay, next, part B. If Q is between R and T, RT is equal to 24 centimeters and QR is equal to 6 centimeters, then what is QT? So Q is between R and T, draw the segments. Alright, just like that. RT, which is the entire segment, the length of RT is equal to 24 centimeters. And then QR is 6 centimeters. What we're trying to find is QT. I don't know it, so when I have it in my segment addition postulate, I'll just leave it as QT. Let's draw out our equation, or write out our equation. We know that RT is equal to RQ plus QT. Okay, so I know RT to be 24 centimeters. Right now I'm just going to put 24. That equals RQ, which is 6 centimeters, plus QT. Subtract 6 from both sides. I have that QT is equal to 18 centimeters. Alright, now we're going to move on, get a little bit harder with some algebra in our statement, but it's the same concept we're doing. But first, we're going to solve for x. We have just an extra step in all that. So, P is between L and A. So, L, A, P. PL is x plus 4. So, I just put x plus 4. PA is 2x minus 1. And LA is just 5x minus 3. Alright, set up our equation like we always do. LA is equal to PL plus PA. Now we want to plug in what we know for each of those. 5x minus 3 is equal to PL, which is x plus 4. And then PA is equal to 2x minus 1. Alright, so 5x minus 3, x plus 2x is equal to 3x, 4 minus 1 is equal to 3. Alright, so now I'm going to subtract 3x from both sides. Subtract 3x from both sides. That'll give me 2x minus 3 is equal to 3x. Oh, nope, that's not what I meant. Excuse me. That tells me, yeah, 2x minus 3 is equal to 3. Sorry. And then I'm going to add 3 to both sides. So 2x is equal to 6. So I divide 2 by both sides for x to give me is equal to 3. Okay, so I found my first part. To find LA, I just plug whatever LA is, so it's 5x minus 3. Plug 3 in for x in that. So right here I have LA is equal to 5 times 3 minus 3. That gives me 15 minus 3. So LA is just 12. Okay, so we have a lot of these examples like this. Okay, so P4 is just like P3. I will work it out for you. And we didn't do it in class because it was just like the previous one, like part C. But let's go ahead and do it. So if F is between E and G, okay, EF is 8x minus 17. FG is 5x minus 3. And then EG is 71. Okay, so what I want to do is same thing we've been doing, okay? So EG is equal to EF plus FG. Alright, so EG is 71, EF is 8x minus 17, FG is 5x minus 3. We do some algebra and solve that. So we have 71 is equal to 13x minus 20. Alright, so I'll add 20 to both sides to get that 13x is equal to 91. Divide both sides by 13, and 91 divided by 13 is 7. Okay. Alrighty. P5. If K is between S and Y, SK is equal to 13Z minus 5, KY is equal to 2Z plus 9, and SY is equal to 36 minus Z. Find each value. Z, SK, KY, and SY. Alright, so first we will use our segment addition postulate, draw out our thing, S, Y, we've got K. SK is 13Z minus 15. KY is 2Z plus 9. Then SY is 36 minus Z. Our equation is SY is equal to SK plus KY. Plugging in, I get 36 minus Z is equal to 13z minus 15 plus 2z plus 9. So then I get, I'm going to clean this up a little bit. So I have 15z, negative 15 plus 9 gives me negative 6. Right? Yeah, negative 6. So let's add z to both sides. Let's also add 6 to both sides. So I get 42 is equal to 16z, right? Yes. And then I made a mistake, I think. No, or did I not? Oh, that was my problem. I see. Everyone stopped me there, I feel like. 13z minus 5 plus 2z plus 9. Yes. Okay, that's what happens when you rush through something. Apologies there. We've got this again. Anyway, so now we've got 36 minus z is equal to 15z plus 4. Okay, now we're going to add z to both sides. Minus 4. Minus 4. That gives me 32, which I was hoping with, I knew was what I was supposed to have. I knew I was making a mistake earlier, is equal to 16z. So z is just equal to 2. Now I'm going to plug in z into for sk. sk is 13 times 2 minus 5. Okay, so sk, if I plug that in my calculator all at once, I can do that. I get 26 minus 5, which would give me 21. Okay, now for ky, I'm going to have 2 times 2 plus 9, which is going to give me 13. So from there, I can find sy by just using the segment addition postulate now. sk plus ky is equal to sy, right? So 21 plus 13 is equal to 34, and we're finished. Okay, cool. Alright, that's the end for this part of Lesson 4.1 video.